What I want to do now is look at graphs of exponential functions and logarithmic functions. And what we'll do is just look at y equals e to the x and y equals natural log of x. So let's do y equals e to the x first, and we'll draw some just some xy axes here, origin in the middle. Y equals e to the x. Now don't forget that e is approximately equal to 2.71828 blah, 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 blah. So it's a number just less than 3. Now let's have a look at the intercepts, and just look at, if x is 0, that means everywhere along the y-axis x is equal to 0. So if you had x equals 0, you've got y equals e to the 0. Any positive number there raised to the power of 0 is just equal to 1. So it's going to cut the x-axis at 1. And because we've got e, a positive base raised to a power, a positive base raised to a power will never be negative. So e is always just a number less than 3. So it is never going to, as x gets small out this way, it's never actually going to cut the x-axis. And we can put in some values, or we can just have a look. Say x is equal to -2. So x equals -2, you got y equals e to the -2, which is 1 over e to the 2. So roughly 1 over 9, say 1 over 8 point something. So as x gets smaller and smaller, so it gets a larger negative number, -2, -4, -20, -100. We got 1 over e to the positive of that one. So this gets larger, and 1 over a very large number approaches 0. So way out here, it is going to get very, 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 very close to the x-axis. So as it gets here, it gets closer to 1. At 0, it actually equals 1. And then x equals, just look at the other side, so 2, we got y equals e to the power of 2, and that's 8 point whatever. And that'll be starting to get quite large. As x gets to 4, it'll be e to the power of 4, which even gets bigger and bigger and bigger. So we get a graph that looks something like this. It's called the exponential function, and that's y equals e to the power of x. If we look at y equals log of x, x and y, and this is y equals natural log of x. The crucial point here is when x is equal to 1, we have the log of 1. Now don't forget what that means. A log is a power. Now this is, our natural log is log to base e of 1. So we want the power we must raise e to get the number 1. Well, that is going to be 0. So y will be equal to 0. So y equals 0 at everywhere along the x-axis. So when x is equal to 1 out here, so our graph is going to cut the x-axis at the point 1. We also know that you cannot have the log of a negative number. So x cannot be negative. So the graph is all going to be on the right-hand side of the y-axis. So x can't be negative. You can't have the logs of negative numbers. You can have a negative log, but you can't have the log of a negative number. So our graph is going to cut there. Now it just remains to be seen, does it come like this or does it come like this? So let's go, if x is equal to, say, halfway between, we've got y equals the ln, the log of a half. And so what we've got to do is to try and work out what we've got to raise the base e to get a half. So e to what power is equal to a half. Now e is 2.7, so to get a number less than e, you've got to raise it to a negative power. So e's got to be raised to a negative power here to get a number less than e. So my y values are going to be coming down here. And as we get closer and closer to x being equal to 0, my y value gets less and less and less. Then as we go through here, as we increase our value x greater than 1, our graph is going to go like that. So there's my graph of y equals ln of x. Now, we should say from the outset here that both y equals e to the x and y equals ln x are functions. There is a simple test for a function, the function test. Now we saw in previous work that the test for an inverse is if we can draw a horizontal line and it cuts the graph twice, then it does not have an inverse. The function test is the vertical line test, so not horizontal but vertical line. And that's if cuts once only, then it's a function. So if I can draw any number of vertical lines and it only cuts the graph once, then it is a function. Now here, there is nowhere I can draw a vertical line where it's going to cut twice. So every vertical line I like to draw there is only going to cut once. So therefore y equals e to the x is a function. Same with y equals ln x. There's nowhere I can draw a line where it's going to cut the graph twice. Even though it looks down here, theoretically, it keeps on going and keeps on getting closer and closer and closer to the y-axis, right down to infinity. So there's nowhere I can cut. Even down here, I cannot, really close to the y-axis, I cannot draw a vertical line that's going to cut the graph twice. So there's the function test. It's a vertical line test, and if it cuts once only, then it's a function. Okay. If I put both of these graphs on the same axes, so let's just do it in the middle here. So my y equals e to the x looks like that. And my y equals ln x will look like that. We've done some work on inverses, and these two graphs are inverses of each other. If you put in a value of x and you calculate the function y equals e to the x, that will map the value x to a new point. If you take that point then and put it in there for lnx, it'll bring you back to the original point. So these two functions are inverses of each other. It doesn't matter which one you start with first. The other one is the inverse of the original one. Now, there is a property of inverse functions. All inverse functions, if I was to draw in here y equals x, so y equals x straight through 45 degrees. These, my sketch here is not 100%, but they are mirror images. If I was to consider a mirror in the graph y equals x, these are reflections in each other in that mirror of y equals x. So the property of mirrors, the distance in front is the distance of the image behind. So these are exact images of each other in the graph of y equals x. Now that's a property of all inverse functions. Doesn't matter, we've just got exponential and logarithmic, but any functions that you can get an inverse for, they are going to be mirror images in the line of y equals x. It has to be in y equals x, will be mirror images. So they are the graphs of y equals e to the x and y equals ln x. Y equals 10 to the x and y equals, now remember, if we don't write a base, it's base 10. They are very, very similar. They still go through the points y equals 1 there and x equals 1 there for the log graph. How do they differ? 10 to the x is a lot steeper, and same over here. So these are once again mirror images of each other, so they are inverses of each other. But they are the graphs of exponential and logarithmic graphs.